All right, let's talk about something every microbiologist has probably run into, an organism that just doesn't quite fit the textbook description. Well, today we're putting one of those right under the microscope. We're going to unravel the mystery of Fusobacterium naviforme.
Now, before we get started, just a quick heads up. Everything we're about to go through is sourced from a really thorough review put together using Gemini Deep Search. If you want to see the raw data, the primary sources, all that good stuff, it's all in the linked notebook document for you to check out.
So, let's get right to it. When your lab flags a Fusobacterium naviforme, what are you actually looking at? And I'm asking this because, trust me, the answer is way more complicated and, honestly, a lot cooler than you'd expect.
Okay, so here's how we're going to tackle this. First, we'll cover the basics, what we think this organism is. Then we'll get into the really juicy part, the identity crisis this bacterium is having. After that, we'll connect the dots to see what this means for clinical diagnostics and treatment. And finally, bring it all back to the bench.
Right, let's start with the fundamentals. What's the standard profile for this bug?
So, on paper, Fusobacterium naviforme is your textbook opportunist. It's a gram-negative, non-spore-forming rod, and it's an obligate anaerobe, meaning it hates oxygen. It just kind of hangs out as part of our normal flora, in the mouth, the gut, you know the drill. But, and this is the key, the moment our defenses are down, say after surgery or some kind of trauma, it seizes chance and can cause some really nasty infections.
Okay, but here's where the story takes a sharp turn. That simple, neat definition we just talked about, well, it turns out it might be completely wrong. This bacterium is having a full-blown identity crisis.
I mean, look at its history. The name has been shuffled around for over a century, which, happens in microbiology. But the real bombshell, the thing that threw everything into question, didn't come from some old classification debate. It came straight from the lab with modern genetic tools.
This all goes back to a game-changing study in 1991. Researchers looked at the clinical isolates, the bugs we actually see in patients, and compared them to the official type strain, the one that defines the species. And what they found was shocking. The G+C content was off by almost 20%. I mean, that's not a species difference, that's a genus-level difference. And if that wasn't enough, even their cell walls were built differently. One used mesodiaminopamilic acid, the other mesolanthanium. They were fundamentally different organisms being called the same name.
So fast forward to today. The genetic evidence is so overwhelming that a very recent 2024 study has officially proposed a solution. Let's move the organism we actually find in patients into a whole new genus. Meet Zandiella naviformis. And this isn't just a name change, it's a huge deal. It basically means we've been misidentifying this pathogen for decades.
And look, this is way more than just some taxonomic squabble for the academics. This identity crisis has real, tangible consequences for what we do in the clinic and in the diagnostic lab every single day.
For starters, think about your routine ID methods. If your MALDI-TOF database is built on that original, non-clinical type strain, you're either going to get a misidentification or no ID at all. This is why 16S rRNA gene sequencing becomes so incredibly important for getting a definitive answer. Clinically, what we're usually seeing are these nasty polymicrobial infections. Think head and neck, chest, abdomen, basically anywhere a breach in our mucosal barrier can give it an entry point.
And here's another fascinating piece of the puzzle. We all know its more infamous cousin, Fusobacterium nucleatum, and its key virulence factor, the FAD-A adhesin, which it uses to stick to our cells. Well, it turns out Fusobacterium naviforme, or Zandiella, doesn't even have the gene for FAD-A at all. This tells us it must have a completely different strategy for setting up shop and causing disease, which is a whole other mystery to solve.
Okay, so let's switch gears and talk about treatment. How do we fight this thing? Unsurprisingly, there aren't any specific guidelines for Fusobacterium naviforme, so what we do is fall back on the general playbook for treating anaerobic infections. And rule number one, before you even reach for an antibiotic, is source control. This is non-negotiable. You have to drain the abscess, clear out any dead tissue, get rid of the source of the infection. If you don't, antibiotics just won't be able to get in there and do their job. It's really the most critical step.
All right, so once source control is handled, what about the drugs? Well, if you look at guidelines for adults, say for a complicated intra-abdominal infection, whether it's the Dutch swab or the international IDSA, you see a pretty consistent strategy. You need something that hits anaerobes hard. So that often means metronidazole paired with something like a cephalosporin, or going for a broader agent like piperacillin tazobactam. The exact choice might change based on local resistance patterns, but the principle is the same. Cover your anaerobes.
Now, for kids, it's the same idea, but with an extra layer of caution. Dosing is absolutely critical. Everything is based on weight to make sure the drug levels are effective but not toxic. So for your go-to anaerobic drugs, metronidazole, clindamycin, piptizo, you've got to be meticulous with those pediatric dosing calculations.
Okay, let's bring it back home to the micro lab. What are the key things we need to look for at the bench?
Well, it does have a pretty classic look. Under the microscope, you're looking for those distinctive, fusiform or boat-shaped gram-negative rods. On the culture side, it's a strict anaerobe, so it's not going to pop up on your routine plates. You need enriched anaerobic media. Biochemically, a positive indole test is a good clue, and it's a butyric acid producer, which can give it that memorable smell. And of course, like any obligate anaerobe, it's naturally resistant to aminoglycosides. Don't even bother testing them.
But here's where we hit a major roadblock: antimicrobial susceptibility testing. The big challenges that UCAST, well, they don't have any species-specific clinical breakpoints for Fusobacterium naviforme. So we're left with a tough question. How do we interpret our MICs?
So what are our options? Thankfully, UCAST doesn't just leave us hanging. They have a clear set of steps to follow. And step 1, the most practical approach for a clinical lab, is to borrow the breakpoints from a closely related species. In this case, our best bet is Fusobacterium necrophorum. It's not perfect, but it's the official recommendation. So here are those surrogate breakpoints from Fusobacterium necrophorum for some of the key antibiotics. But, and this is so important, if you report out a susceptibility based on this, you absolutely have to include a comment. You have to let the clinician know that the interpretation is based on breakpoints from a different, though related species. Clarity is everything here.
So, as we start to wrap this up, it's pretty clear that Fusobacterium naviforme is more than just another bug. It's a fantastic example of how microbiology is constantly evolving and how what we know today might change tomorrow.
This whole situation with its identity isn't just a fun fact. As this quote points out, this ambiguity throws a wrench into everything. It makes it incredibly difficult to look back at old clinical data, because who knows which organism they were really talking about. It forces us to be much more critical and to rely on molecular methods to know for sure what we're dealing with.
And really, that leads to a much bigger question, doesn't it? A question for all of us in the lab. If this one known species was actually two different things hiding in plain sight, how many others are out there? What other secrets are buried in our databases, just waiting to be discovered?
If you want to go deeper on this, all the sources are in that linked notebook document. Thanks so much for tuning into this explainer. If you found this interesting, make sure to subscribe for more, and definitely drop your thoughts or any questions you have in the comments. We'd love to hear from you.